Hello friends, welcome back to Flux Electrical Engineering YouTube channel. Today we will discuss another type of circuit breaker called air blast circuit breakers. High voltage can cause air to ionize, creating a conductive pathway. This process occurs when the voltage is strong enough to break down the air's insulation properties, allowing electricity to flow through it. In this class, we will analyze how we can make air as an arc-quenching medium in air blast circuit breakers, despite its conductive properties at high voltages. We will examine the configuration techniques that make this possible. So, stay tuned as we start. Welcome back. An air blast circuit breaker, ABCB, is a type of electrical circuit breaker that uses a high-pressure air to extinguish electrical arcs when interrupting electrical circuits. ABCBs are designed to operate in high-voltage transmission systems, providing reliable and efficient circuit protection. Having known what air blast circuit breaker is, let us now explore how air blast circuit breakers operate. The working principle of air blast circuit breakers, ABCBs, is based on the use of compressed air to extinguish electrical arcs that form when interrupting electrical fault current in a circuit. When fault occurs, the protective relay detects the fault in the electrical circuit. The relay sends a trip signal to the air blast circuit breaker, which causes the contacts to separate. An arc is initiated due to the ionization of the air gap. The arc is sustained by the flow of current through the ionized air. As the arc develops, the high-pressure air blast is released, which rapidly cools the arc, reducing its temperature and ionization. The air blast also blows away the ionized particles, increasing the dielectric strength of the gap. As the arc is cooled and the ionized particles are removed, the arc resistance increases, ultimately leading to arc extinction. The air blast circuit breaker's design ensures that the arc is extinguished quickly and efficiently, minimizing the risk of damage to electrical equipment. So, this is how ABCB clears fault in power system and protect electrical equipment. As we have covered the working principle of ABCBs, now we will analyze the types of air blast circuit breakers. Air blast circuit breakers, ABCBs, are classified into several types based on the direction of the air pressure that is used to extinguish the electrical arc. The type of ABCB used depends on the specific application and the requirements of the system. The first type we will analyze is axial blast type. The axial blast type of air blast circuit breaker is designed where the air pressure is directed along the arc path. This means that the compressed air is blown axially along the arc, which helps to cool and extinguish it quickly. The axial blast is particularly effective in high-voltage transmission systems where fast and reliable arc extinction is needed. The axial blast type offers several benefits, including fast arc extinction. By directing the compressed air along the arc path, the axial blast helps to cool and extinguish the arc quickly, which reduces the risk of damage to the circuit breaker and other equipment. Fast arc extinction is critical in high-voltage transmission systems, as it helps to minimize the duration of faults and prevent damage to equipment. Furthermore, the axial blast type helps to increase the dielectric strength of the gap between the contacts. By blowing compressed air along the arc path, the axial blast helps to remove ionized particles and increase the dielectric strength of the gap. This reduces the risk of reignition and ensures reliable operation of the circuit breaker. So, this is how axial type of air circuit breakers works. Another type of air blast circuit breaker we will look at is cross blast type. The cross-blast type of air blast circuit breaker, ABCB, is designed where the air blast is directed at right angles to the arc path. When an arc forms between the contacts of the circuit breaker, the compressed air is blown the arc across, effectively cooling and extinguishing it. This design is particularly useful in applications where the arc is longer and more unstable, as the cross-blast helps to rapidly cool the arc and increase its resistance, ultimately leading to arc extinction. The cross-blast type is well suited for applications where the arc path is complex or unpredictable. By directing the compressed air across the arc, the cross-blast type can effectively cool and extinguish the arc, even in cases where the arc is longer and more unstable. This makes it a versatile design that can be used in a variety of applications, including those where the arc path is not well defined, or is subject to variation. One of the key benefits of the cross-blast type is its ability to provide effective arc extinction. This effective arc extinction reduces the risk of damage to the circuit breaker and other equipment, minimizing downtime and maintenance costs. Because it can be used in a variety of applications, including those where the arc path is complex or unpredictable, the cross-blast type is a popular choice for many users. Its ability to provide effective arc extinction in a wide range of applications makes it a reliable and versatile design. So, this is all about the cross-blast type circuit breakers. The last type of air blast circuit breaker we will analyze today is radial blast type. The radial blast type of air blast circuit breaker, ABCB, is designed where the air blast is directed radially outward from the center of the arc. When the contacts of the circuit breakers open during fault clearance, an arc is formed between the contacts, a compressed air is blown radially outward, effectively cooling and extinguishing the arc. This design is particularly useful in applications where the arc is highly unstable, and requires a strong and directed air blast to extinguish it. In the radial blast type, the compressed air is directed radially outward from the center of the arc, which helps to rapidly cool the arc and increase its resistance. This rapid cooling and increase in resistance ultimately lead to arc extinction. The radial blast type is designed to provide high arc extinction capability, even in cases where the arc is highly unstable. By directing the compressed air radially outward, the radial blast type can effectively cool and extinguish the arc, reducing the risk of damage to the circuit breaker and other equipment. Its design makes it well suited for applications where high-speed fault clearance is essential for maintaining system stability and reliability. By providing high arc extinction capability, the radial blast type helps to minimize downtime and maintenance costs, ensuring reliable operation of the power system. One of the key benefits of the radial blast type is its ability to provide reliable arc extinction. The radial blast type is designed to provide consistent and reliable performance, even in demanding applications. So, this is all about the radial blast circuit breakers. Dear friends, if you like this tutorial, please support the channel by liking and subscribing to the channel. It will help you get updated on my upcoming videos on power systems. Thank you for doing that. Let us continue. Now that we have covered the types of air blast circuit breakers, where can it find its applications? Air blast circuit breakers, ABCBs, have a wide range of applications in power systems due to their reliability, speed, and efficiency. These applications include the followings. 1. High-voltage transmission lines. ABCBs are used to protect high-voltage transmission lines from faults, such as short circuits and overloads. By quickly interrupting the circuit in the event of a fault, ABCBs help prevent damage to the transmission lines and ensure reliable power transmission. This is particularly important in high-voltage transmission systems, where faults can have significant consequences for the entire power grid. 2. Substations. ABCBs are also used in substations to protect electrical equipment, such as transformers and switchgear. By providing reliable and efficient circuit protection, ABCBs help ensure the safe operation of substations and prevent damage to equipment. This is critical for maintaining the overall reliability and efficiency of the power grid. 3. Interconnected networks. ABCBs are used in interconnected networks to ensure reliable power transmission and distribution. These circuit breakers help to quickly clear faults and prevent them from propagating through the network, ensuring that the power grid remains stable and reliable. This is particularly important in modern power systems, where interconnected networks are increasingly common. Lastly, industrial applications. Air blast circuit breakers are also used in industrial applications, such as arc furnaces, rolling mills, and other high-power electrical systems. In these applications, ABCBs provide reliable and efficient circuit protection, helping to prevent damage to equipment and ensure safe operation. This is critical for maintaining production efficiency and preventing costly downtime. Summarily, ABCBs play a critical role in ensuring the reliable and efficient operation of high-voltage transmission systems. Their speed, reliability, and efficiency make them an essential component of modern power grids. So, this is all about air blast circuit breakers applications. Having known the areas of application of air blast circuit breakers, what are the limitations of using it in power systems? While they offer several advantages, ABCBs also have some significant disadvantages that need to be considered. One of the primary concerns with ABCBs is that they require a compressed air pump system to operate. This means that the compressed air system needs to be maintained regularly to ensure reliable operation of the circuit breaker. The maintenance requirements for the compressed air system can add to the overall maintenance costs and complexity of the system. For instance, the compressed air system requires regular inspections to ensure that it is functioning correctly, and that there are no leaks or other issues. Additionally, the air filters need to be maintained to ensure that the air is clean and dry, and that the filters are not clogged. The compressor also needs to be properly lubricated and maintained to ensure reliable operation. Another limitation of ABCBs is that they can be noisy during operation. The compressed air blast that is used to extinguish the arc generates a significant amount of noise. This can be a concern in certain applications, such as in residential areas or in environments where noise levels need to be minimized. The noise level can be significant, and it may require additional measures to reduce the noise level. For example, noise-reducing materials, or silences can be used to mitigate the noise. ABCBs are also susceptible to air pressure leakage, which can impact their performance and reliability. Air pressure leakage can occur due to a variety of reasons, including seal failure, pipe damage, or valve failure. When air pressure leakage occurs, it can lead to a decrease in the air pressure, which can impact the ability of the circuit breaker to extinguish the arc. This can lead to a decrease in the reliability of the circuit breaker and potentially cause faults or equipment damage. The potential for air pressure leakage can be mitigated by implementing a regular maintenance schedule and using high-quality seals and pipes. Regular inspections can help detect any potential leaks or issues, and replacing seals and pipes can minimize the risk of air pressure leakage. Additionally, using valves that are designed to minimize the risk of leakage can also help mitigate this issue. So, these are the limitations of the air blast circuit breakers. As we have known the limitations of air blast circuit breakers, why are we interested in it? Air blast circuit breakers, ABCBs, offer several advantages that make them an ideal choice for high-voltage transmission systems. Some of the key benefits of air blast circuit breakers include the followings. 1. Fast operation. Air blast circuit breakers are designed to interrupt faults quickly, reducing the risk of damage to electrical equipment. Their fast operation ensures that faults are cleared before they can cause significant damage to the system. This is particularly important in high-voltage transmission systems, where faults can have far-reaching consequences. 2. Reliability. Air blast circuit breakers are designed to operate reliably in high-voltage transmission systems. Their robust design and construction ensure that they can withstand the stresses of high-voltage operation, providing reliable fault clearance and minimizing downtime. The reliability of ABCBs is critical in high-voltage transmission systems, where faults can have significant consequences. 3. Low maintenance. ABCBs require less maintenance compared to other types of circuit breakers. Their simple and robust design ensures that they can operate reliably with minimal maintenance, reducing downtime and maintenance costs. The low maintenance requirements of ABCBs make them an attractive option for high-voltage transmission systems, where maintenance can be challenging and costly. Lastly, high short-circuit capacity. Air blast circuit breakers can handle high short-circuit currents, making them suitable for high-voltage transmission systems. Their high short-circuit capacity ensures that they can interrupt faults quickly and reliably, even in the most demanding applications. The high short-circuit capacity of ABCBs makes them an ideal choice for high-voltage transmission systems. Air blast circuit breakers can handle the high short-circuit currents encountered in high-voltage transmission systems, ensuring reliable fault clearance and minimizing downtime. So, these are the key reasons why we are interested in air blast circuit breakers. In conclusion, air blast circuit breakers, ABCBs, are a reliable and effective solution for high-voltage transmission systems. Their ability to provide fast and reliable arc extinction, high dielectric strength, and flexibility in design make them a popular choice for many applications. Even though the compressed air systems can be noisy, but their benefits make them a valuable component in power systems. By leveraging the strengths of ABCBs, engineers and technicians can ensure reliable and efficient operation of their electrical infrastructure. Here, we bring the class to an end. If this tutorial is helpful to you, please like and subscribe to the channel for my upcoming videos on power systems. You can also check out my video on other types of high-voltage circuit breakers through the link in the description box below. Thank you for watching, and I will see you in my next class.